So next up is level 10.3, which is all about ellipses. So as we saw before, ellipses are when you cut a cone through, you get this oblong circle. So this is a more expanded case out for a circle. So we call those ellipses. And how you construct those is if you put 2 points, so 2 thumbtacks like this picture says, and we wrapped a string around these 2. If I stretched a pencil out so that the string was taut, and I wrapped that around, just based off these 2 fixed points, we would get an ellipse. So let's read that definition again. An ellipse is the collection of all points in the plane, the sum of whose distance from 2 fixed points, called the foci, is constant. So what does that mean? Well, if we have some distance here and some distance here, what we're going to get is we're going to get a triangle, and no matter what we have, this distance is always going to be the exact same from this line and this line. Okay? So let's just look at the points of interest that we have to have. With our center, that we're going to call that H comma K. Our foci, 2 points on the inside of the ellipse, and we usually use C to represent the foci. The major axis is the longest side. So the axes, meaning we have 2. We have 1 here and 1 here. Our major axis is our longest side, and our minor axis is our shorter side. So how we always distinguish between those two is we always call the major axis A and our minor axis B. It's just how we do it, okay? So let's first look at an ellipse with the center at the origin. If we have the center at the origin, we have x squared over a squared plus y squared over b squared equals 1. The foci are given by this. This is our super big important equation. We either have, so since A is the longest side, we have a squared equals b squared plus c squared. Or if we're solving for one of these other sides, this is our main thing that we're going to use. So you can see that theirs is played around with a little bit. What they did was they subtract the c squared, so they had a squared minus c squared equals b squared. So usually we're going to do one of these two. We're going to have a and b, and we're going to try and find c. As long as you know that a is the longest side, then we're going to be able to utilize this. Now notice, since the a, our longest side, is under the x, this is like an elongated ellipse along the x-axis. If the a was under the y, then it would be a tall ellipse. So based off of this, we're going to try a couple examples. Example 1, find an equation of the ellipse with the center at the origin. Okay, so that's our HK is at 0, 0. One focus is at, so that's our C, which is 3, 0, and our vertex, and the vertex at -4, 0. So I want to first plot these points and then see what we get to write the equation. It's always super important. Graph what you can and then go from there. So at 0, 0, that's our center. So we're going to label that C for center. One focus is at 3, 0. So 1, 2, 3. That's our focus. So that means our other focus is at 1, 2, 3, the other way. So we have 2 foci. The plural for focus is foci with this equation. Then it says we have one vertex at -4, 0. So one vertex is at -4, 0. So that's our vertex, which means we have another one on the other side at 4, 0. This is going to be our major axis because the vertex and the foci is always on the same side as the major axis. Okay? So the foci is always on the major axis. Okay, so how do we figure out what the distance is from here to here? Well, we can count. 1, 2, 3, 4. So A equals 4. And we have little c equals, that's the distance from the center to the focus, is 3. So if we wanted to find our minor axis, we had on the other side b squared equals a squared minus c squared, which is a form of the Pythagorean theorem which we should be familiar with. So this is b squared equals 16 minus 9. So if we do this, 16 minus 9 is 7. So b squared equals 7. So b equals the square root of 7. So that doesn't really have a nice number, but we can guesstimate that 7 is between 4 and 9. So the square root of 7 is going to be between 3 and 2. And it's a little closer to 3 than it is to 2, because 7 is a little closer to 9 than it is to 4. So if I go up between 2 and 3, that's going to be another vertex. And then if I go down 1, 2, 3, and that's going to be another one of my vertices. So to graph our ellipse, we connect vertice to vertice, and we get our little football shape. So there's our ellipse. And then to write the equation, it's x squared over a squared plus y squared over b squared equals 1. It's always going to be equal to 1. So our a squared we know is 4. So that is 16, because that's 4 squared. So x squared over 16 plus y squared over 7, because our b squared is 7, equals 1. So that's our equation. And all we had to do was be able to graph the information. All right, let's try the reverse. Analyze the equation. And again, just like in 10.2, analyze means find the center, find the major axes, find the foci, and the vertices of the ellipse, and graph it. Okay? So our a squared is 25, so a equals 5. Our b squared equals 9, so b equals 3. So we've already got that as a start. We notice that there's no numbers next to x and y, so our our center is at 0, 0. And what we can do is graph this. I always like to start with a graph, because the more we graph it, the more we see. So, graph and label. There's our center. Our A is 5 along the x, so we go 1, 2, 3, 4, 5. Label it. 1, 2, 3, 4, 5. The other direction. Label it. Then on the y, we go up 3. 1, 2, 3, because that's the number under the y. And then we go down 3. 1, 2, 3. And label it. So our foci is going to lie on the same plane as our major axis. So we sketch our ellipse in here. Let's see if I can get it. So there's our ellipse. We have our center, which is at 0, 0. Our major axes is A, so our major is 5. So if we wanted to label our vertices, we would be at 5, 0, negative 5, 0. And then our minor would be at 0, 3, and 0, negative 3. So those are all of our vertices. To find our foci, Our foci is b squared equals a squared minus c squared, or we could also say c squared equals a squared minus b squared if we just switch these two. So that means we have c squared equals 25 minus 9. So c squared equals 16. So c equals 4. So our foci would be along our major axes. So 1, 2, 3, 4. And then 1, 2, 3, 4. So our two foci are at 4, 0, and negative 4, 0. So let's see. Did we find the center? We found the major axes. We found the foci and the vertices of the ellipse. Do you have to write these all out? No. As long as I can see this on your graph, you should be good. All right, flip it over. Now, what happens when the major axis is along the y-axis? You can see that we have a tall ellipse as opposed to a long ellipse. And that's all if the a is under the y. So oftentimes the book always writes the x squared first, but we can be smart and always write the y squared over the a squared first if you want. Otherwise, everything else stays the same. We just have to make sure that when we're given the information, we graph it correctly. So let's look at example 3. If we're given this equation, 9x squared plus y squared equals 9. So what did we say was to analyze? Find the center, find the major and minor axes, find the foci, find the vertices, and graph it. So first thing we have to do, we need to get it equal to 1. That means divide everything through by 9. So if we divide that by 9, we're left with x squared over 1 plus y squared over 9 equals 1. So you can see that what's the bigger number here? Well, the 9 is obviously the bigger. So if we went ahead and graphed this, we know that there's no x squared, there's no numbers next to the x squared or y squared, so our center is at 0, 0. So our center is 0, 0. Now, this means we go 1 to the right, that's one vertice. If we go 1 to the left, that's another vertice. So our b squared equals 1, so b equals 1. Our a, which is our bigger number, is 9. So a equals 3. So we go 3 up on the y, and we go 3 down on the y. So we can see that this is a tall one because the longer side is along the y. So if I sketch this out, it looks more like a circle. Still a little chubby for a circle, but most of my circles aren't that good anyways. So we have our vertices in here. We could label them if we wanted to. This would be 0, 3, 0, negative 3. This is 1, 0, and negative 1, 0. Now, where would our foci be? Our foci are along the major axis, so our longer axes. So how do we find that? Well, we have b squared equals a squared minus c squared. So our b squared is 1 equals 9 minus c squared. So we could flip these two. So c squared equals 9 minus 1. So c squared equals 8, or c equals the square root of 8, which is 2 square root of 2. Now, the square root of 8 is really close to 3. So how do I know that's really close to 3? Because 8's really close to 9. So that's one foci, and then there's another one of our foci. So if we really wanted to write it out, our two foci would be at 0, 2 root 2 and 0, negative 2 root 2. Those are the exact values that we approximated on our graph. Now, did we find everything? Did we graph? Found the focus, found the center, found the vertices, found the major and minor axes. See, when we started, it looks more complicated than it actually is. All right, a few more examples. Find an equation of an ellipse having one focus at 0, 2, and the vertices at 0, -3, and 0, 3. Graph the equation. So always start graphing. Always be graphing. If you do that, you're less likely to mess up. Graph and label. So we have one vertice at 0, -3. So 1, 2, 3. Vertex. 1, 2, 3. Vertex. We have a focus at 0, 2. So that means we have to have another focus at 0, -2, which means our center is at 0, 0. So our center is 0, 0, and you see why we'll write it in just a second. Our A, our longest distance, is 1, 2, 3. Our C is 1, 2. So to find B, B squared equals A squared minus C squared. So B squared equals 9 minus 4, which is 5. We don't need to actually take the square root of this because we're just finding the equation. So our equation is going to be x squared over 5 plus y squared over 9 equals 1. And if we really wanted to, this is just over 2, so 1, 2, that would be a vertice. And if I got 1, 2, just past 2, is another one of my vertices. I know that's a lot of black, so let's put some color in there. And you can see this kind of looks like a circle, but it should be a little stretched out. Now it's due to my scale and being able to draw it, but what we know is this is our equation that works, and that's what our graph looks like. All right, flip it over. We're going to move our center around, which really doesn't change a whole lot besides doing more completing the square. So like I said, I gave you this nice big box just like we did for level 10.2. So if we have our major axes over under our x squared, that means we're going to have a long one, a long ellipse. And if we have our major axes under our y squared, that means we're going to have a tall ellipse. And then the h and k, all that does is move our center around. If we want to find the a, all we're doing is counting from the center out. Same thing with our focus. We're counting from the center out. Nothing new. We should be good with just moving these shapes around. All we're doing are transformations, which is pretty straightforward. So let's look at example 5. Find the equation for the ellipse with the center at 2, -3. So center, 2, -3. One focus at 3, -3. One vertex at 5, -3. Graph the equation. Okay. Always be graphing. Always be graphing. If you can graph it, you can figure out the equation. So, there's our graph. Let's go to our focus, or center first is at 2, 1, 2, -3, 1, 2, 3. Label it. So there's our center. We have a focus at 3, -3. 3, -3. That's our focus. And we have a vertex at 5, -3. So 4, 5, 5, -3. That's a vertex. So if I counted 1, our focus is 1 away from the center. So if I went 1 the opposite way, we get another focus. Our vertex is 1, 2, 3 away. So if I went the other way, 1, 2, 3 away, I get my other vertex. We see that this is all the major axis. So what we're going to do, our A was, again, 1, 2, 3 away. So our A is 3. Our C is 1 away. So B squared equals A squared minus C squared. I write it every single time so I remember it. So B squared equals 9 minus 1. So B squared equals 8, or 2 root 2. If we take this, b equals 2 root 2, I should say. So it's asking to find the equation and graph it. So 2 root 2 is really close to 3. So if I go from my center, which is right here, at 2, negative 3, and I go up almost 3, I'm at one vertex. If I go down almost 3, I would be at my other. So now it's just a game of connect the dots, connect the V's. So V to V, connect the V's. Same down here. This is why it's super helpful to label all of your points. Now we just have to assemble our equation. So we see that this is along the x-axis, so our x is going to have our largest number. So our equation is going to be x minus 2, because that's where our center is, squared over a squared plus y minus a negative 3 squared over our b squared, which is 8, equals 1. So that's our equation based off of our center, our a, and our b that we found. Few more, and then we are all done with ellipses. Sorry I misspoke. It meant we have one more, and then we're done with ellipses. So again, analyze the graph, only this time it's a little more messy because we have to do completing the square twice. So it's nothing more that we can't do, we just got to get to it. So first off, we're going to group the x's together. 4x squared minus 8x, and then we're going to leave a little space. Then we're going to group the y squareds together, so y squared plus 4y, and then we're going to move the number over to the other side. So that's negative 4. So next up, factor out the 4. That'd be x squared minus 2x, and let's just go complete the square. So half of negative 2 squared is 1. Whatever we do to one side, we do to the other, so that's 4 times 1, so we add 4. Plus y squared plus 4y. Half of that in squared is 4. Whatever we do to one side, we do to the other, so plus 4. All right, now we have 4 parentheses, x minus 1 squared plus y plus 2 squared equals negative 4 plus 4 is 0 plus 4 is 4. So then the last thing, this has to be equal to 1. So we divide everything through by 4. Divide by 4, divide by 4. So this is x minus 1 squared over 1 plus y plus 2 squared over 4 equals 1. This is our ellipse. Our a is along our y, so our a equals 2. Our b equals 1. So our center, our c, b squared equals a squared minus c squared, or c squared equals a squared minus b squared. So our c squared equals 4 minus 1, which is 3. So c equals the square root of 3. So that's not that pretty. But it's just under 2. It's like 1.86. Our center here is at 1, negative 2. We have everything we need now, so all we have to do is graph. So we start at our center, 1, negative 2. Label it. Now let's just count. We know that we go up 2 and down 2 on the y, so we go up 2, 1, 2. There's our vertex. Then we go down 2. There's our vertex. We go 1 to the left and right, so 1 here, 1 here. Our foci is just under 2, so it's just below our vertices along our y, and then we connect the dots. So that's everything that we have to do to analyze this equation. We found the center, we have our vertices labeled, we have our foci labeled. If you have this labeled, you are set. So what should we know about ellipses. So I would say the foci are along the major axes and are on the inside of the ellipse. So that's one thing. The other thing that's really important is b squared equals a squared minus c squared, where a is the largest number and c is the foci distance from the center. And then the last thing if you can graph it, you can write the equation. So those are the things that I want you to be able to do to analyze ellipses. So that's our second conic section.